roll up, get your games here. 50 games, but just 50 games, ideal for the kiddies, everyone a winner. Step up, young man, step up. Oh, what's that game there, mister? 50 games, 50, for the price of $9.95. Look at this glorious cassette here, professionally produced, as modelled by my associate Terence. Wow, that's amazing. But wait, that's not all. It also comes with a fully functional digital watch. Show off, Tez. And I could use a watch. It's handy, this, Arthur. It's 10 minutes time for you to get me a drink. Parasite. Today we're looking at the legendary Cassette 50 in a Snorkers way. Cassette 50 is a game that had 50 games on one cassette for a low price, plus you got a free digital watch. All the games on the tape are legendarily not very good, and all of them have 3 character names. So the first game on the tape is Mun, or Munster Munch. Takes about a minute to load and does not auto-run. And it's a basic game. And you can see here there's what looks like a maze with graphic blocks, full stops, asterisks, and that. It is a Pac-Man clone, written entirely in BASIC. The information description is rather nicely done, printed one letter at a time. You are in a maze, 2 monsters will follow you into a button and try to eat you. You can eat asterisks, sick, and you'll get a power pill. There are exits both sides, you only have a limited amount of power. This is a nice little effect, to be fair, with the little beeping. Your keys are Q and Z, I and P. Well, that's weird for a start, I don't approve of that. But press enter to play and let's see what we've got. We have 2 monsters at either corner of the maze. There's animation on the Pac-Man knockoff. When you eat a power pill, the monsters turn green, but they continue to pursue you, so they're actually running towards their own death, or undeath if you prefer, if they're ghosts. The graphics for the Pac-Man and the ghosts are actually quite nice. The power pill's a bit hard to see, just a red asterisk, but they're not too bad. And it's adequate. The AI of the monsters isn't the most fancy. They try and move directly towards you unless there's a wall in the way. They can cut corners, which can catch you out. Little sound with the secret passage, but they can easily be blocked. You can just hold them behind walls while you collect all the treasure. It moves at a reasonable pace for a basic game. With a couple of monsters. No bonuses, nothing special like that. Collect the treasure, try and clear the screen. The other monsters are trapped in a little corridor. I'm going to eat them. Whenever you eat them, your kills appear at the bottom. And then the monsters return to their original corners. Killed ghosts return to their corners, so it's possible, if you really want to, just trap them in the corner, sit your Pac-Man on top of them while they constantly respawn and die. Which is a little bit silly. And unfortunately my power pills run out, the letter 0 appears randomly at the bottom of the page, and the text is splattered over the top of the maze. I'm a goner, spelt wrong. High score is 334, my score 334, kills 23. Let's make it better. This is my first attempt to make it better. Not changed this bit much, but I have changed the keys to be QAOP as Sir Clive intended. First change, you can see there are 4 ghosts. And the ghosts are all different colours. So 4 ghosts, different parts of the screen, red, cyan, black and magenta. Ghosts can still move diagonally though, which is a bit of a problem. As here, they're killed me by moving diagonally. After taking a power pill, all the ghosts change colour, as you'd expect, but now they run away from Pac-Man, not towards him, which seems more realistic. You may have also noticed that the game is slower. There's a lot more going on, and it's gone from being an adequate speed for a rather dull Pac-Man clone to being, this is annoying and no longer even remotely fun. Oh, and now my power pool's worn out, and the ghosts are chasing me. And I'm dead. Back in the centre. I made this improvement some time ago, and then left it because I realised I'd actually made it worse. What was a playable but unimaginative game became an unplayable, imaginative game. Unfortunately, you're not going to play that long because you're going to get bored to tears with everything being so slow. Now Pac-Man's going into the corner, and I've killed a ghost in the corner, and I've not fixed the corner squatting problem either. Oh dear. But on death, I now clear the screen, make it nice and tidy, and I've corrected the spelling of goner. But where can we go from here? Oh, this basic game is really slow. Whatever can I do?
Hey kid, and that's what you need.
What? Those magic buttons will make it better?
Finest magic buttons, oh yeah.
Wow, that sounds amazing. I'm sure there's no catch. Starting in your spectrum, AnQL user, issue 3, we get adding zip. What is zip? It is a frankly astonishing basic compiler by Simon Goodwin. BASIC is an interpreted language. In the late 1970s, a series of benchmarks were put together, 1 to 7, with some standard BASIC, and then repeatedly run to see how long they take. You see here from your Spectrum issue 3 that the zip compiler promises massive improvements on 7 of the 8 benchmarks, but is unable to run the 8th. This is because the zip compiler has some restrictions, including only supporting integer maths. The zip compiler promises massive improvements in performance by removing the searching and the interpreting and replacing them with static code. The first thing you're going to need to do is enter the library code. The way the zip compiler works, it takes BASIC, it converts BASIC into an intermediate language, and then takes that intermediate language and turns that into machine code. Intermediate subroutines such as var fetch, which is entirely Mr. Goodwin's creation, and then looks these up in a vector table of machine code, which you need to type in. First of all, though, to make your life easier, is a short little basic program pictured here, and then you've got all these numbers to type in. There are checksums, though, which just make your life easier because you know when you've made a mistake. This will take you about an hour. I say you because, unfortunately, I cannot share the compiler with you. The source is available in your Spectrum. You can look it up either on the Spectrum Computing website. There are better scans available on World of Spectrum. This is something that you'll need to do if you want to use the zip compiler. We now move on to your Spectrum AnQL user number 4, where we actually get to type in the compiler itself. But first of all, Mr. Goodwin explains how it works and the importance of doing proper software design, which makes it a lot better. There are 2 pages of BASIC, but there's 3 columns, so there is quite a lot to get through. There are several things you need to watch out for. Mr. Goodwin was rather annoyed with your Spectrum because they mucked up the typesetting rather badly. There is a splodge of ink on every single copy, which hides the actual number it should have been, and there are also bits that are mixed up. So in the next issue, your Spectrum AnQL user, issue 5, he wrote in a rather grumpy letter explaining in a basic program what you need to do to correct it. The zip compiler does not support every basic keyword you might want to use. There are a list here of the basic ones you can use. Most things are there. Complex maths is out, as are string functions. You can print strings, that's perfectly fine, but you cannot have string variables or string arrays. You also cannot have multi-dimensional numeric arrays. You can't do plot, you can't do draw. Now, Mr. Goodwin realised that not being able to do some of these things is a bit of an issue. So in issue 5 of your Spectrum AnQL user, he added the machine code to allow you to use plot and draw. You can only draw straight lines, though. Let's leap ahead now to issue 7 of your Spectrum and QL user, where Mr. Goodwin again has to write in a correction where the checksum of the new machine code for plot and draw is incorrect and somebody missed out a call to a subroutine. Let's leap ahead to issue 10 of your Spectrum and QL user, where a 70-year-old writes in saying they finally got the zip compiler to work after working out that line 6755 contains a lowercase l in the brackets u plus l and not a 1. The 2 lines above have L as a capital, so you might be expecting that to be a 1. No, it's an L. If you make it a 1, then the binary search for the go-to lines never ever finishes. And this took me days to debug. Got those corrections done? Issue 6 contains a basic program called Starbase, written to highlight the use of the zip compiler. Mr. Goodwin realises that not having the ability to beep, not having the ability to use rand, and not having the ability to use in keys were impediments to game development. So he shows here you can use a small snippet of machine code to get sound effects, and gives some examples of how you can use the basic in command to read the keyboard and a way of generating random-ish numbers. So let's get this typed in.
Do I observe a bird?
Is that a bird?
No. Is that a bird? Do I observe a play?
Is that a play?
Is that a drink?
No.
I do not think I do.
No.
I think it's...
This program, Starbase, was written to show the power of the zip compiler. Starbase is a graphics game with sound effects. You find yourself in the space station at the centre of the screen, with green meanies tumbling towards you from all directions. Armed only with a super sub-meson warp laser, and a limited supply of sub-mesons, you must repel the alien hordes in the usual manner. You can swivel the laser to point in any direction, but you must be quick. The longer you play, the faster the game gets and the more aliens attack at once. As it stands, says Mr. Goodwin, Starbase is a simple but addictive game. It will be easy to enhance it by adding user-defined graphics, orbiting aliens, high score tables and so on. The listing only occupies about a third of the memory available to Zip, so there's plenty of room for extra features should you feel enthusiastic. In basic, the game is very slow, especially at the higher levels when up to 5 aliens can attack you at once. The program starts by asking you to enter the speed factor. Even 0, the highest speed, is pretty slothful in basic. Zip is clearly called for. So here is Starbase in basic by Simon N. Goodwin. 7 go clockwise, 6 anti-clockwise, and 0 is far. Off it starts, and the screen goes black and then fills with an attractive star field. And at the Starbase hyperspace scanner, you must press a key to start. And here we go. We are the Starbase in the centre. The evil O's, possibly Mr. On, to come into attack. We move the space cannon around, press 0 to fire, a line is drawn, we get a beep, you get a score. And the border is changing rather nicely. It's rather pretty. It is a little bit slow. Over time, it does get faster and you get more and more aliens showing up. But essentially, this is the game. You move your gun around and try and shoot the aliens. Note there is limited ammunition as well. Oh, I'm missing there. But there's sound, there's motion. It's pleasant. The only thing you'll say is it's a little bit slow. Moving forward now towards the end of the game, I've been going for a while, I've got a score of 690, and now you can see I've got multiple aliens coming in. There are 3 of them. I'm trying to swing my gun around to get them. You can get multiple aliens with one shot with a bit of luck. There's 3 coming in now. It caters for up to 5 aliens coming in to get you. But eventually, you are going to get overwhelmed. And the more aliens on the screen, the more score you get, which is a nice touch. And again, it gets faster and faster as you go along. But obviously, it's basic, so it never gets that fast. And there's an attractive game over screen where a bit of basic code changes the attributes of the screen through all the possible ink and paper colours, which is attractive. But as you can see here, it's rather slow. But yeah, the thought is there. So how do we compile it? We load the compiler. The compiler then loads the library code for Run 5000.
and you need to merge in, with the merge command, the basic code. Basic code can be anything under line 5000. And the first thing it does a pass one of the basic to make sure that everything is tickety-boo. There are no lines we can't have. So remember, you load the compiler loads the library code that you've typed in, you then merge in with merge your basic program, and then you can run 5035. And it takes its time. But you're in basic. Here I've sped it up now. This is 5000% speed, which is something like 50 times faster. So you can still hear we're going through the code. All the basic is there. As it's a sample, there are no errors. Everything here is supported, so it all works fine. And at the end of it, we get told this takes about 15 minutes. As you can see there, the timer is not on the spectrum. Yet 73 lines and 0 errors. We now move on to the compile phase, where it goes through each line and produces, first of all, intermediate code and then the actual machine code for us. It does this line at a time. Obviously, line 10 was a rem statement, which is a comment, so is line 20. So those don't count, those get ignored. When you get to a dim statement, they don't produce any machine code. It just makes a note for later that there is some variable to worry about. If you have an array, it must be dimensioned in advance. You cannot redimension it. And you can't have an array which is calculated in size. So here, again, we're up to line 100 already. We've had produced 0 bytes of machine code. Now means you're actually producing genuine code now because we're actually doing some stuff. I've now accelerated this to 50 times speed, so you can see it goes through each line, producing more and more bytes. It is not a fast compiler. However, you've typed it in yourself in BASIC, which means it's pretty much free if you're subscribed to your Spectrum and QL user. So do bear that in mind. And if you're using an emulator on modern systems, you can just crank the speed up like I have. You can crank the speed up to 20 times in the emulator, which is I would recommend if you are compiling it yourself, unless you have something else that you want to do. Because it's not fast, and it takes, let's say, a good 55 minutes at least in the first version that you've typed in. And that includes the initial scan. After it's done the first scan, it then needs to go through and then update all the go-tos, because it can't know where the machine code is for later lines until it's done them. So it makes it know, I need to do go to 300, and later when it goes back and fills in what the real machine code is. And then we get told, save code 53247, that's the library code, plus your code, 5195. To run the program, you randomise user prog, which is the variable, or 55012. So let's do that and run our newly compiled machine code version of Simon Goodwin's Starbase. Randomise USR prog will execute the machine code starting at address 55012. Notice it's exactly the same, apart from the cursor is a solid block. Enter the delay factor. 0 is the fastest. Let's go with 0. I want to go as fast as possible. Let's see what this baby can do. And here we go. Press a key to start, and here it comes. Oh, and I'm dead. You can see here the full game over effect. And that was very nicely done. Let's try it again. Randomise user prog. And let's put in 100 of delay factor. It's still pretty fast, but I've got some of the aliens at least. This is much more like it. The problem we now have is it runs a bit fast, which is why we have the ability to enter the delay factor. Let's try 1000. That's better. Now remember, as the game progresses, the delay factor will reduce. This is in the basic program, and therefore is carried forward into the machine code, so it'll get faster and faster until we're going at full pelt. But we have sounds, we have motion. This is pretty good. But can we make it better? Captain Zip, Captain Zip. The basic compiler, Captain Zip, Captain Zip. The basic compiler. Another page, another splodge. The bugs are there for you to dodge. Type the code in if you can. Basic compilation man. From your spectrum, he's on his way. It's Captain Zip to save the day. Before we make things better, Mr. Goodwin has another improvement for us. A performance improvement. A single line of BASIC will improve the performance of the compiler by around 50%. Because BASIC looks up variables in a table, the table is produced in order of definition. That's definition. Whenever let statement happens, it gets put into the table. As the table gets bigger and bigger, there's more to search. So you will need to make sure that your variables that you use all the time are at the start of this table. And that's what this single line of BASIC does. Let's Snorkify Starbase. I'm going to make 3 improvements. I want to use user-defined graphics for the alien spacecraft and the explosion. I want to use a special sci-fi font. And I want to have the number of enemies be configurable from 5 all the way up to 10. A big advantage of the Zip compiler is because your code is in BASIC, you should be able to run it and test it before you compile. So you don't have to write in machine code first. You can run your BASIC code. It should work. It'll just be a little bit slow. And let's feed that into the compiler and we'll see that it really doesn't like that calculation. There is a maths calculator which is pretty good, but it doesn't like the poke USR so-and-so formulation. We have input with a string attached. We can have input asking you a question. That's not supported. The standard way of doing user-defined graphics is to have a series of data statements which we read in a loop, and then we poke the user-defined variable address, which is provided by USR and then a string. We can't do that. However, we can poke. We can poke to an address. We can calculate what the user-defined variable address is and put that address in instead. We can't use data statements or read, so we can just put the numbers in, as you can see here, in a fairly standard way. Not the most efficient way of doing things, but once compiled, it'll be pretty fast. This is our 3rd attempt at compiling after fixing various problems. The first thing we do, we go through all the BASIC, display the BASIC. We don't care about rem statements. But here are my changes where I'm poking 65480 with 0, 65481 with 0, etc, etc. These are my user-defined graphics code. It's happy with these. Let's accelerate the speed to make sure there's no other problems. It'll do a first pass and then it might find problems in the compilation phase. This is after his performance boost as well. So note it's taken about 10 minutes already, whereas last time it took 15 minutes to get this far. And the whole thing now takes 37 minutes, not about an hour. To finish snorkification, I'm using Ben Stavros machine code here, which takes the Spectrum font and copies certain bits of each font at certain rows to make a sort of sci-fi effect. And this here is the loader program. You see we set the clear, we load a screen, we load a font, we set the font appropriately, we then load the machine code, and then we run it. I always like to put together loading screens for my little Snorkify games. We have a cyan starbase with some nice grid lines on it, shooting a magenta laser at some green flat flying saucers against a background of stars. The bottom 2 rows are in the sci-fi font flashing to highlight the work done by Mr. Goodwin with the starbase and the Zip compiler. And here's the Snorkified version. This sci-fi font adds a touch of class, plus the adding of the configurable enemies, which is something Mr. Goodwin suggests. I'll make it easily configurable without having to recompile it. You don't get 10 enemies to start with, it builds up to a maximum of 10. The more enemies you have on the screen, the quicker the enemies come. So let's see what it looks like. Again, press a key to start. And you get, attractive flying saucers. And then you do a zap, and you get a nice explosion. Marvellous.
Have no fear! Zip is here!
Oh.
You not stop me, Captain Zip.
Oh.
Oh, thanks, Captain Zip. What do I do now?
It's all very well typing in a demo program, but we want to use Zip to make existing basic programs better. First thing, load it into memory without the compiler, and then have a good look at the listing, making notes about what needs to change. Restore isn't allowed. Let high equals 0, that's a 2-character variable name, and go sub 9000, that line is too high. As we move on, make notes of variable names that are too long, any use of a string, for example R string, that's right out. You've got a multi-dimensional string array, that is not going to be allowed. But these are things we can fix. In keys, we know there's a workaround for in keys. We know there's a workaround for random. We know there's a workaround for beep. At the end of the program, we go above line 5000. That's where the compiler lives, so we have to move this code. This is mostly the data. You can't have data statements, which is going to be used for defining UDGs. You can define UDGs, but it's not in this way. And then they've got a really nice effect where they define the text for the screen and then print it out one character at a time while beeping. We won't be able to do that. So first thing you're really going to want to do is move anything above line 5000 below 5000. After doing that, load up the compiler and just try and give it a go. You're going to get hundreds and hundreds of errors, but that's okay. One thing you might want to consider is with variable names, you're only allowed 26 variables with the zip compiler. So after running and making a note of what you can't have, for example, high is well out, you can run the normal basic program and then after breaking into the code, trying to find out what letters are used, A, B, A to Z. Give that a try. But we know most of these problems. We know we can't have strings. We know we can't have beep. Our big problem is changing the multi-dimensional string array into a one-dimensional numeric array. That's relatively simple to do, but now we have the problem of the characters. So I first of all try letting each element of the array be the code of the relevant character. Unfortunately, the zip compiler does not support the keyword code, but we can look up what the number of the character is and put that in instead. This works fine. It also makes the program incredibly bloated, increasing it in size from about 7K to 14K. This is a problem because when you try and load it into memory along with the compiler, it says, The zip compiler is a basic compiler with a machine code component, but the basic code you load in has to fit in memory as well. In addition to that, it generates machine code. There's got to be room for that, and of course the room for the tables or the lookup of the lines that you need as well. It's all got to cram in. One way of saving memory in basic programs is to convert numbers into strings and then reference them using val. You can't do that with zip. However, you can have variables which are numbers and use those instead. So I've done that. W represents the wall, because there's lots of walls. So I've given that a try, and it's not enough. Then I thought, okay, what do we actually need? We need an area of memory which contains a series of bytes. A numeric array is bad for that because it's going to be multiple bytes per entry, because that's how big numbers are. What if we just use a memory address directly and then poke it? Still not enough space. I then sat back and rethought how I was poking in the values for the maze. You have an outer wall. In the middle of the maze, most of the time it's going to be pellets that you eat. There are exceptions. Those are the walls and the power pills. Power pills are only 8 of those. But the walls, they come in sequences of 6, 4, 3, 8. You group all of those with similar numbers together, and then you can reduce the number of for statements down dramatically. Still not enough. Right, we move the code that generates the UDGs from the Munster Munch program into a loader program that we're going to need anyway to load the machine code nicely. We also move the code that loads the beep machine code in there as well. That saves a bit more space. Still not enough. Right, we now look at the basic of the compiler and we're able to shave off some space by turning some numbers into actual strings with val. And that finally gives us enough space to squeeze in our code. Let's now look at the compiled Munster Munch Snorkified. It's loaded. Again, you can't tell the difference apart from I've now said there are Munsters, not just 2 Munsters. And there's a question, how many Munsters 1 to 4? Look at the cursor, it's a solid block. Keys are now QAOP, as God intended. And speed, and I go for the fastest possible speed, which still has a small delay in it. But the speed goes from 1 to 10, and off we go. Well, that's fast. Here comes the cyan ghost. I picked up a power pill. The ghosts now return to their corners. And when you eat a ghost, it'll return to its corner. However, if you are already in the corner, then the ghost will go back to where you start. And if a ghost kills you, here comes the magenta ghost. Oh, I've got a power pill now. Oh no, they're coming for me. So when you die, you go back to the centre, and the ghost that kills you goes back to his corner. And this is nice and fast. Dazzlingly so. And here they come again. Will I clear the screen? Will I clear the screen? No, I will not. I'm a gunner old bean. My score is 400, kills 3.
What ho! Terence, be a dear. I ain't fighting him, Arthur.
As an additional challenge, I thought I'd look at the snorkified version of Thro The Wall that I did a few months ago. Thro The Wall has some advantages in that the machine code and the user-defined graphics are already loaded as separate components. You just need to move the loading of those to the loader program. From there, we just need to look at it and see what we've got, what needs to be replaced. You've got the standard variables are a bit too long. You've got beep, you've got rand. One thing of concern that we need to fix is Thro The Wall makes extensive use of variable-based go-tos and go-subs, where you basically put a line number into a variable, in this case it's G, and then go to that instead of a hard-coded number. We do not support that in Zip. However, it's easy to fix because if you know what the numbers are going to be, you just simply put in if G is 120, then go to 120, and that is supported. What I really wanted to keep from Thro The Wall, though, was the big chunky messages you get on the screen. These were a bit of a pain. Zip doesn't support strings. The subroutine, however, pokes the strings into memory from the string, which is fine. So all we need to do is move the strings directly into memory. I first tried this using code. We can't use code. And then was just poking the ASCII values into memory. And then I ran out of memory in BASIC itself. This is not a clever way of doing things. So I decided what I'm going to do is have 50-byte blocks in memory. And of those, the first byte will be the length. The next 3 would be the position and the magnification factors. And then the strings. And the strings were just normal strings. And then I just used the code keyword, which is perfectly fine in normal BASIC, to poke this into memory. That left me with the score. The score at the end is displayed in big letters on the screen. But that's using the string function, which again we don't support. So what I did was take the score and then extract from that by using integer divided by thousands, divided by 100, divided by 10, the thousands, hundreds, tens and units. Put that into memory, add 48 to them to get the ASCII character, which is the digit, and then use that as the string. Works fine, except we then have leading zeros. And that was a bit tricky fixing that in the space we had, so I stuck in a new subroutine where essentially we go for each digit. Is this digit greater than 0? If so, leave the subroutine. If not, make it space and look at the next one. Apart from the units, of course, where if the units are 0, then we leave them as 0. And let's now look at Zip in action with Thro The Wall. Stop the tape. We've still got a nice big chunky text, just like before. I've not bothered changing the description. And it's moving at a nice speed. You can make it a lot faster if you really want to, but then it becomes unplayable. But the bat moves back and forth. We've got little beeps and boops. I couldn't use beep, but I've made equivalent chirps. You'll notice that compared to the snorkified version, the score is at the top of the screen. In the snorkified version, the score was printed on the bottom 2 rows of the screen using print #0. That isn't possible using Zip. You can't do that. So I put the score at the top, on the top row, and the explanation of the power-up on the row below that. So I had to bring the top of the screen down. So there's a bit less space above the bricks. But apart from that, it's really rather nice. There's an art to these games when it comes to how much do you slow it down, how fast is fun, and when do you let the player move. With multi-ball, because you have multiple balls flying around, it still slows down quite a lot because you move up to 4 balls in one version I tried, and then it's just not fun. But this is rather jolly. You can't use screen string in Zip to determine what's on the screen. However, Thro The Wall never did it anyway. It used the attribute keyword, which is still used, so that's fine. That's completely unchanged. So either use what colour is this square I'm moving into to determine I've hit something, but you can't use screen string. The Munster Munch thing didn't use that. It used the contents of an array to determine if you hit something, which is less elegant, but is good because the monsters were constantly printed over the top of what was on the screen anyway. So. And by hitting the flashing brick, we get one of the 2 power-ups, Sticky Bat, which is on the second row. By holding down symbol shift, you should be able to make the ball stick to the bat. Just about. Keyboard inputs are a little bit finicky, but it does just about work. You can, because it's Sticky Bat, the ball sticks to the bat and you can drag it around to release it, which should make it at least a bit more releasable. Can I clear the screen? That's a no. And here's the score. Is it big? Yes, it is big, with a leading space. Now I'll leave you with a message from Captain Zip.
Captain Zip doesn't work alone. He relies on viewers like you to help. Today's video is thanks to the Mike DX. As a boy, he discovered the secret of the Zip compiler and used that to write games at home. The Zip compiler moved on from the 1980s, became a commercial release, and finally ended up as a 128K version on a cover tape. But now, its secrets are lost to time. Fortunately, he writes other stuff too. Check him out on GitHub and on YouTube, and follow him on Twitter. Thanks, Mike.
Captain Zip, Captain Zip, the basic compiler. Captain Zip, Captain Zip, the basic compiler. His logic tuned, he's lightning fast. Slow basic is in the past. One by one the keywords turn to quick machine code you can learn. Step by step save space and time. Simon Goodwin is so fine. Captain Zip, Captain Zip, the basic compiler. Captain Zip, Captain Zip, the basic compiler. A man of steel, a man of lust. Water over him and he will rust. Captain, Captain Zip, the basic compiler. Captain Zip.